Hello and welcome back. This is Lesson 4, Part 2, Operators and Decision Making, using Scratch. In Scratch Lesson 4, Part 1, we created the 6 different objects in our stage, each having either a different color or a different shape. And we're using decision making and operators to determine which shape to simply move across our screen. We already created this code, which is the code we used for all the objects. If you haven't put this code into your Scratch editor, you should pause this video and do this now, or go back and look at Scratch Lesson 4 Part 1 so that you actually do have this code to build on. This lesson will continue where we left off the other day. So if you remember, we have actually two global variables that we've created already. We have the color and the shape global variables that are usable by all the different objects in this particular stage. And we've also created some variables for particular objects. For example, the red circle. Well, we're going to make one. It's called position. The reason we want to do that is because if we move one of these objects over to the right side of our screen, the next time we move it, we want to actually move it back. So if it's on the left, we want to move it to the right, and if it's on the right, we want to move it back to the left. So in order to do that, we have to keep track of what position it has. So to start with, we're going to do this for the red circle, and then make sure the code works, and if it's working fine, we're going to duplicate that code for the other 5 objects on our screen. So to begin with, we have to decide whether it's on the left or the right, or the machine has to be able to know whether it's on the left or right. Obviously, as a human, we can see immediately where it is, but the machine doesn't understand any of that. It has to be told. So we're going to start by making a data or a variable called position. This position variable is going to be for this sprite only, because each sprite has its own unique position on the screen. So this is what we call a local variable, and we're going to call it position. And create it for this sprite, the red circle. And then, notice how it comes up here, and it actually defines it as a red circle's position because it knows we might be creating a position variable for other objects, which is exactly what we'll do. Since it's on the left side of our screen, I'm just going to move it over here where it's a little bit more out of the way. And then I'm going to create some code for it. So under control, I'm going to use the if decision-making structure. If decision-making structures are very valuable and quite powerful in all programming languages. And I'm going to be a little more specific. I'm going to go if then. And to begin with, I'm going to move these other two where we set the variables back to 0 again out of here, because we want that to be at the very end of our code. And since the code executes sequentially from top to bottom, this should be at the very bottom of our code. Now this if code block is actually designed so that it will test a condition here inside this hexagonal area, which we haven't done yet but will do soon. And if it evaluates to true, it will execute all the code blocks that I've put that are going to be in this first section of this whole if statement. If this evaluates to false, though, it jumps past this first section, goes to the else, and executes this else portion. It never executes both. It executes one or the other depending on what this condition evaluates to. So if it evaluates to true, it will execute all the statements in the first section, and if it evaluates to false, it'll jump over to here and evaluate all the false or all the statements in this section. And then once it's done, it comes out of here and it continues on through the code. So this if statement, I'm going to create an operator and go equal to, and we're going to set the position variable. If the position of one of these objects is on the left, then we're going to move it to the right, and if it's on the right, we're going to move it to the left. So our actions depend on the position of the particular object with this if statement. So I'm going to go back to my data categories, choose the position variable, and say if it's equal to left, which means the object is on the left side of the screen, then clearly I'll want to glide it to the right hand side of the screen, which is what this statement did right here. So I'm going to move that glide statement into my if block. And so if you remember, if we choose color red and the shape is a circle, then this is obviously referring to this particular red circle object, which this code is for. It will glide to this position across the screen, which it did in the last lesson, part 1. Now we're going to check to see if its position is on the left. If it's on the left, we're definitely going to make it move to the right. And if it's on the right, we're going to make it move to the left. So clearly that brings up the issue. This position variable is not set to anything to begin with. So when our program starts, all these objects are on the left-hand side. We have to initialize this position variable to say that it is starting off on the left. So we're going to set the position to the left when this program first kicks off. As soon as we press the green arrow, the position variable says left. So there it is, sitting on the left-hand side of the screen. And we're going to say if it's on the left, it glides to this position. But if it's not on the left, there's only one other option. It's on the right. We don't have to make another. We don't have to test for that, because in our simple program it can only be in one of two positions. So if it's not on the left, if this is false, we know it must be on the right, and therefore we're going to take this glide statement, duplicate it, but change it so it glides from x20, y150, or glides back to where it is now, and its position right now is actually at x negative 150, and y 150, I'm not even going to change that, because the y we're not going to change. So let's just check this out right now and see. Oh, actually there's going to be a mistake if I leave it the way it is. Let's try it and see what happens with the code the way it is. So I'm going to run this code, press the M key. It asks me which color I'd like to move. Since I've only done the code for the red circle, I'm going to use red circle. Red circle. And let's watch closely what happens to these variables as this program executes. I hit enter, and it does exactly as it should. It moves the red circle to this position. And then of course it resets these back to 0, so that for my next move I may move something else and it's ready to go. Notice the red circle's position still says left. It's not on the left anymore, it's on the right. So if I go to move again, hit the M for move, and I choose red circle, what do you think will happen? Well, it's already on the right, and since the position is still saying left, it's going to try gliding right to where it already is, and it actually will not move anywhere. So I hit enter, it just stays there. So we have an issue. I wanted this to move back to where it started. To do that, it's a simple little trick. This is an important little programming skill that you'll use in many different areas. But for this case, we're going to set the position. If the position is left and we move it, we have to update the position variable, and now the position variable is obviously on the right. If I can just spell that properly, R-I-G-H-T. But if the position's on the right, then it moves to here, and of course this section of code will move it back to the left. So I have to duplicate and put, since it's moved it to the left, I'm going to have to update the position variable here and say left. So this glide position moved me to the left, and therefore I have to update my position variable to say left. This glide moved me to the right, and I have to update my position to say right. So now this position will actually change appropriately with the position of the red circle. Let's reset, and let's try that again. I hit M for move, red circle. We moved it to here, but now let's say I want to move it again, so I hit M. I go red circle. This time, notice how it's updated the position variable to say right. Therefore, it's going to move it back to the left, because it's going to come to this statement here and say if the position's left, which it isn't, so this is false. It doesn't execute the first chunk of code, it jumps to the next portion of code, and it actually glides from x to x negative 150, y50, which is right here, and updates my position variable again, jumps out of my if block of code, and then resets the shape and colors to 0, which you'll see set when it goes back. There it goes. The position is on the left. It's changed these shape and color variables back to 0. so that it doesn't have any retained values to mess up any movements I might make with my other objects. Okay, so this seems to be working pretty good. Let's add one more thing to this before we start to duplicate the code for the other objects. We chose to, in this initial wait command here, we were testing to see if the color was red and the shape was a circle. How about if we want to move both red objects at the same time? I want to move this circle and the square. If they're both red, I want to move both of them. So we can do that. We can simply pull this out, and I'm going to zoom in on this code a little bit so you can see it better. I wonder if I can expand the window somewhat. I can't really do it while I'm recording, so I'll just leave it where it is. I'm going to actually put another decision-making structure in here. It's going to be the OR statement, or the OR qualifier. So the color has to be red, and one of these two conditions will have to be true. The shape will be a circle. Whoop, put it in here. Or, let's see if I can get this to move over. Whoop, I can't. I lost it. No, I think I actually did lose it by moving it over. So I'm going to see if I can undo. Okay, I had to actually recreate this code because I messed it up, but I've got it back here. So like I said, I'm going to move this out and use the OR operator. OR basically says that if this condition is true or this condition is true, then the whole thing evaluates to true. It's less restrictive than the AND qualifier because only one of these two conditions needs to be true for this whole thing to be true. So if the shape is a circle, or shape equals all, I'm going to say. So I'm going to go back to here and go shape. Oops, I first have to actually go equals all, which means when I type in all, I'll want to move all my shapes. So if I choose to say all when I say red and I go all, it'll move the square and the circle for me. Or at least it should do that. Then we're in good shape. Let's run this code and let's try it out. I go M, let's red, and let's go all. As soon as I type in all, shape now is all. It's going to be equal to all. So this is true. This is also true. So this side of the AND, the left side of the AND is true, and the right hand side of the AND is true. Therefore, it's all true. It's going to move the position to the right and then jump out of here. Oh, I did forget to update my variables when I paused for a minute, so I'm just going to go into here and put those back in. Those were there before, but I lost them. Set position to right and set this position to left. Let's run this. Red, all. Ooh, I definitely moved something. I screwed something up. So let's see what happened here. I moved it down to this lowest position. So obviously I glided to the wrong spot. X was 20, Y is not negative 150. It should be 150. And clearly the red square didn't move. The reason for that, and I should have known better, is because if I look at the red square's code, I don't have any of that code in there for the red square. So I'm going to have to come back to here. I'm going to duplicate all of this, and I'm going to drop it on everything. And I'm just going to have to make sure that I properly clean up the code for everything here. Make the modifications as necessary, excuse me, for each particular object. So for the green circle, I'll take, actually I didn't need to be too draconian about this. I probably didn't need the wait until, because it's already, well, I'll do it. I'll chop that out, and I'll move this in here. So if the color is, this is a green circle, so if I make this green, and the shape is not, yeah, we're talking about a circle, that's fine, or shape is all, that's good. If the position's on the left, which is fine, then glide to the position over here. However, its coordinates will be a little bit different. Its y coordinate will be 100, not 150, which was the red circle. So I'm going to change that right here. And you'll notice I need to make a position variable for this green circle, which I haven't done. Even though I have a position variable for the red circle, I need a position for all of these objects. So I'm going to go to make a variable, and it's going to be for this sprite only. I'm going to call it position, the exact same name I used for the red circle. But the program recognizes that this position variable is different than the other because it belongs solely to this sprite. So I go OK, and I say if position is left, then make it right, and if position is right, move it over and make it left. And then I set these back to 0. I just have to set my position to start with to the left because that's where all the objects start at the beginning of this program. There we go. That's the green circle. And you know, sure enough, I'll probably be making a mistake here when I do this because that's part of programming. We're doing the blue circle, so this should now be blue. It is a circle, so that's fine. And its y position should be 50. X is negative 150, so x is negative. Y should be 50, not 150. And this is still fine. I still have to make the shape variable for this one as well. Or not shape, sorry, position. Only for this sprite. Click OK. And set it initially to the left, because all objects start on the left. By the way, I'm just going to stop this and there it is, it moved it over. Notice how all these, they show you the values that these variables are initialized to on the screen. This is useful, especially for debugging. I'm going to leave this on here. They're all at the left to begin with, which they should be. And if I didn't make any mistakes, that should work for the blue circle. Let's go to the red square now. Chop this out. And of course red is fine, but it's not a circle anymore, it's a square. Whoops. And its position's on the left. Yes, we just don't want it, we want to move it, we want the y to be 0. Not 000, just 0. And this is fine. I have to make a position variable for this one too. Only for this sprite. Okay. Set it to left to begin with. Good. So all the code is more or less the same for all of these, but with small changes to its position. This one was negative 150, or negative 50. It needs a variable called position. Again, a local variable, which we initialize to the left of the screen. No surprise. And finally, the blue square, same deal. But it's a blue square. Oftentimes you forget to change one variable or one value here when you're doing something like this, and that's quite normal. Sometimes you look at your code for a long time wondering what the heck you did wrong, and really it's a simple thing like changing a small little parameter like that. So don't get too discouraged, but debugging is a natural part of programming, and sometimes it can seem like a long and tedious process, but it helps you make you a better programmer in the long run. And even the very best programmers make mistakes, and they do it all the time. Okay, so everything's starting on the left. I'm moving things here. This needs to be a y position of -100. Okay, and what the heck, let's see what happens now. I'm moving all these guys over to here so I can see my objects better to start with. Okay, and we'll see what happens with our code. So I will go back to the start things off. I will press the M key, we'll press red, and we're going to go all. So hopefully if everything works right now, I've chosen red. So if I, for example, look at the code for the red circle, will the color be red? Yes, the color is red, so that's true. But I also need one of these two things here to be true for this section of code to execute. I'm going to choose all, so will the shape be equal to all? Yes, this is true. Since only one of these need to be true, this whole side is true and is going to work because the left-hand side and the right-hand side of the and are both true. Therefore, it will execute this next piece of code. Is the position on the left? Let's see, is the red circle's position on the left? Yes. So it will now go into this piece of code and say glide for 1 second from x or to x20 y150. Hopefully that'll move it over. It will set the position of the red circle to right because it will now be on the right. It will jump past this else block of code, reset these variables to 0. So the red circle should move. How about the red square? Well, the color will be red and the shape will actually not be square, the shape will be all. So these two, this will also be true. This entire condition will evaluate to true just like it did before. If the position's on the left, well, let's see, is the red square position on the left? Yes. Since that's true, it will go to this chunk of code, glide for 1 second to x20 y0. So hopefully the red square will move over. It'll go past the else and reset the shape and color variables. So let's go hit enter. Oops, back to here, hit enter, and I got my green square to move. Well, like I said earlier, I know exactly what happened here. I forgot to update the parameters for the green square. The red colors did move like I wanted, but the green, I forgot to change its color to green here. No big deal. And is it a circle? No, it isn't. It's a square. So that was another mistake. It would probably screw me up down the road. And that's more like it. Let's just check the red. Good. And the blue is fine. Okay. So let's reset. Start again, and let's try it one more time. Choose red. Of course, you have to type red properly, R-E-D. And let's go all. So the square and the circle should move. There they go. Let's do this one more time. Let's go M to move things, and let's choose red and go all. Now, according to this, the positions have now updated. The red circle and the red square will now, notice they're on the right-hand side of the screen. And of course, the other variables of the positions of the other objects have stayed left, just as they should. So now that they're on the right-hand side of the screen, is the position left? No, it's not. That's false. So instead of executing this first chunk of code, it should go to the next chunk of code and move it back to the left again. And once it's on the left, it sets a position variable back to the left. So let's see how this works here. It worked just fine. So let's just, to properly debug things, you need to test a lot of different possibilities and make sure it's working as it's intended. Let's just move the square back. So hopefully the blue circle remains over there. Perfect. Let's try the green square. You should try all possibilities and combinations you can think of to robustly test a program, because usually it works for many cases. In some unique weird little situations it doesn't work and you have to go back and check your code. I forgot what I typed in. Let's go square. Great. And let's move both red over. Well, there you go. And let's move the blue circle back. Seems to be working fine. Let's try excuse me, let's try the red square. Okay. It satisfies me that it's pretty much doing as it's supposed to. If you don't like these variables showing up on your screen, as you recall, you can simply just delete these guys off here for each object, and it doesn't clutter up your screen. You can also just go to the actual variable on the screen, right click it, and choose hide. It's not gone, it's just hidden. So that looks a lot cleaner. And that concludes lesson number 4, Operators and Decision Making, Part 2. I would go back and type all this code in just as I did. We will likely build from this code later on. So be sure you are trying this as I go through it. Pause the videos as you need and make sure you try this. If you run into problems, replay the video or ask for help. Thanks for watching, and we'll see you for lesson 5, where we do functions and making code blocks.